So good morning all students. Today we will discuss the wonderful KGF trick for hydrolysis. Means sometimes you get stuck what will be the compound, means what will be the gas will going to produce upon hydrolysis. Many time in competitive exam it is also asked. So we are going to begin some tips and trick to solve the problems regarding the hydrolysis reaction that we are going to discuss. So let us begin. The smart, handsome, the Rocky Bhai we have, he will help you out in dealing with the hydrolysis reaction. So idea regarding it. Nitride, if any compound contain nitride, on reacting with water it will form ammonia gas. Hydride, on reacting with water it will form the hydrogen gas. Phosphide, reacting with water it will form phosphine gas, that is PH3. Carbide, carbon 4 minus, on reacting with water it will form the methane gas. And sulphide, on reacting with water it will form the hydrogen sulphide. So this is a general idea that the given compounds, if the compound contain nitride ion N3 minus, upon hydrolysis it will form ammonia. Similarly, hydride forms hydrogen gas, phosphide form phosphine gas, carbide form methane gas, and sulphide forms the hydrogen sulphide, H2S gas. Now this is the idea given here. How the application will be there, with some example all thing will become completely clear, right? All the idea will be completely clear with the examples. So let us begin. The hydrides, that is done, we are doing the hydrolysis of the nitride here. Now nitride, word is nitride, right? Nitride is present. Formula for this is N3 minus. So the radical nitrogen carries minus 3 charge, right? Charge is minus 3. To stabilize this minus 3, we need cation which has a positive charge, right? We know that charge is minus 3. To make it 0, we need to add plus 3. Only then it will become 0. So N3 minus, and we know in water, so water consists of H plus as well as the OH minus, right? Water consists of H plus and OH minus. So if we do the hydrolysis, means N3 minus reacting with H plus and OH minus. So there is H plus and there is OH minus, correct? Now N3 minus, nitride is carrying minus charge. Hydroxide, this is hydroxide. Hydroxide also carries negative charge. Negative charges attract or repel. Negative charges attract or repel. It will be only repelling. It will be only repelling in nature. So only opposite charges will attract here. So H plus ion, commonly known as the proton, right? Hydrogen ion, or we can say simply hydrogen ion. So negative and positive will attract. So H plus carries plus 1 charge, OH carries minus 1 charge. So to stabilize this minus 3, we need 3 H plus ion. We need 3 H plus ion. So simply we can say N3 minus plus 3 H plus OH minus. Here the hydrogen will combine with 3H plus and it will form the following compound. They will form the NH3. In this way NH3 formation takes place. So if I take one example of a reaction, so this is an ammonia gas. So if I take a reaction, lithium Li3N, Li3N, lithium carries plus 1 charge and this one carries minus 3 charge. So this react with water molecule, right? This react with the water molecule and it will form the LiOH plus formation of ammonia formation takes place. So here nitride carries minus 3 charge. To stabilize this minus 3 charge, we need 3 hydrogens, right? And here total, how many hydrogens mentioned? So H plus and OH minus. So you take it 3 times. And here the nitrogen is there. So there is a formation of 3 LiOH formation takes place, right? OH carries -1 charge, lithium carries +1 charge. So they are stabilized. Nitrogen carries -3 charge and hydrogen carries +1 charge. Overall, in this manner, it is completely balanced. Let me show some other examples also. Let me show some other example. Again, another example will be very useful in clearing other doubts also. Let me remove this all here. Suppose I take the example of calcium nitride. Okay. Ca3 and 2. Calcium commonly has the +2 charge. Nitrogen carries -3 charge. Correct? Calcium carries +2 charge and nitrogen carries -3 charge. And how many nitrogen atoms are there? 2. There are 2 nitrogen atoms are here. So simply we can remember water molecule means here H2O is there, means it consists of H plus as well as the OH minus. So here there are 2 nitrogen atoms, each carrying -3 charge. So overall charge of nitrogen here in this case, overall charge will become how much? -6 for nitrogen. So to stabilize this -6 charge, we need 6 H plus ions, right? We need 6 H plus ion to stabilize this -6 charge. So you do this 6 here. So hence there is a formation of, so directly we write there are 2 nitrogen on the left hand side. So 2 nitrogen on the right hand side. Charge is -6. So we need 6 H plus ion. So H3. So 2 into 3, that is 6. So here this is carrying +1 charge, this is carrying -3 charge. So we can say 2 multiplied by -3. Let me write 2 multiplied by -3, it is 6, and 2 multiplied by +1 into 3, overall it becomes 0. So in this way the charge of nitrogen and hydrogen will be stabilized. And what about the calcium? So there are 3 calcium, no problem. 3 calcium is there, Ca, and OH is there. OH carries -1 charge. To stabilize this +2, we need 2 OH minus. Here there are 3 calcium, means total +6 charge. To stabilize this +6 charge, we need OH minus, that is 6 OH minus. Now see, in this way the balancing has been done, right? In this way the balancing has been done. Other example also we can take. Okay, other example for this we can also understand. So always the main target is that opposite charges should balance each other. Opposite charges should balance each other. Only that way the balancing will be done. Okay. So other example regarding is, we can take another one. We have magnesium nitride, Mg3 and 2. So this is your magnesium nitride. Always remember all the alkaline earth metal, that is the beryllium, magnesium, calcium, strontium, barium, these all will have the +2 oxidation number, means they will have the +2 charge. This is magnesium nitride, I am taking the example, right? So one magnesium is carrying +2 charge. Here there are 3 magnesium, 3 into 2, it is +6. Here the nitrogen carries -3 charge. So 2 nitrogens are there, 2 into 3, 2 into -3, that is -6. So in this way the charge are balanced. When the charge are balanced, the compound becomes stable. Now here we are doing the hydrolysis, reacting with water, and we know water consists of H plus ion and OH minus ion here, correct? Water consists of H plus and OH minus ion. So nitride, one nitride ion N3 minus contain -3 charge. So it will stabilize by 3H plus. Here there are 2 nitrogen atoms. Here there are 2 nitrogen atoms. So 2 into -3, it is -6. So here to stabilize the -6 charge, we need 6 H plus ion. It is only possible by multiplying with 6. Hence the reaction becomes N nitrogen carrying minus 3 charge. So there are 2 nitrogen. Overall charge become minus 6. And 1 H plus contain plus 1 charge. So 3 hydrogens plus 3. To stabilize this minus 6 charge of nitride, we need 6 H plus ion. So in this way, the ammonia gas formation takes place and they are completely balanced in this manner. So always remember, hydrogen has plus 1 charge, nitride carries minus 3 charge. So 6 H plus, if you want to understand better, 2 into minus 3 charge of nitrogen, that is in the form of nitride, plus 2 into 3 and into plus 1 oxidation number. So overall, if you add up, minus 6 plus 6 equal to 0. So in this way, ammonia compound is balanced. What about the magnesium? On the left hand side, there is 3 magnesium. So we write 3 Mg, right? And here we have taken 6 OH. So 6 H2O is taken. So there will be OH minus ion also. So there will be OH, because charge on magnesium is plus 2. To stabilize that, we need OH minus 2. So in this way, the balancing of the magnesium will be done. So hydrolysis of nitride is carried out in this manner. In this manner, the hydrolysis is being carried out and we are getting the NH3 as our product. Okay. So other examples we can easily see. So here is the other example. Nitrogen carries plus 1 oxidation number. Nitrogen carries minus 3. Water consists of H plus and OH minus. So it will forming this compound. If you want to do the balancing, you just have to add the water molecule here. Right. So simply you have to balance, write 3 LiOH and here 3 H2O in this manner. Similarly for beryllium nitride, beryllium carries plus 2 charge and 3 beryllium atoms. Okay, charge on 3 Be in Be3 N2. So here the 3 beryllium atoms and each beryllium has plus 2 charge. Overall it becomes plus 6 charge. 1 nitride, charge on nitride, charge on nitrogen in Be3 N2. Simply we can say here. So how many nitrogen? 2 nitrogen. Each nitrogen carries minus 3 charge. So overall it becomes minus 6 charge in this manner. Right? To stabilize this minus 6 charge, we need 6 H plus ion. Only then it will form. Right? So here on the left hand side there are 2 nitrogen. On the right hand side there should be 2 nitrogen. Right? So charge on ammonia we can also balance out. Charge on ammonia also we can balance out. Nitrogen is in the minus 3 oxidation number. Hydrogen is in plus 1 oxidation number. So they will balance out in this manner. And this is the balancing. So in this way we do the balancing of the charges. So how to do the balancing? So we can show the charge. Charge of NH3. We are going to do the balancing. So 1 nitrogen carries minus 3 charge. So there are 2 nitrogen atom, 2 into minus 3. This is a charge on nitrogen. Because 2 nitrogen atoms are there, each nitrogen has minus 3 charge. And there are 2 multiplied by 3 hydrogen atom and each hydrogen carries plus 1 charge. So if you balance this, it will be minus 6 plus 6, overall charge becomes 0. In this way the compound is balanced. Similarly, beryllium hydroxide will be also balanced in this manner. So in this way you can do the hydrolysis of nitride. In short, if you treat the hydride with water, it will form the ammonia gas, that is NH3. Okay, in this way the NH3 gas formation takes place. Other examples are here. Beryllium nitride treating with water, it will form the nitrogen gas. So beryllium, magnesium, calcium, strontium, barium, all the alkaline earth metal nitrides, they will give the ammonia gas. They will give the ammonia gas. And one important thing, on going down the group, stability of nitride decreases. Stability of nitrides decreases. So this is a useful thing. Sometimes the order will be asked. You have to be very careful. Stability of nitrides decreases due to increase in size of cation. Increase in size of cation. So this is the actual reason. So if we have to compare among the alkaline earth metal, which is the most stable nitride, so then in that case beryllium nitride, this one will be the most stable. In the alkali metal nitrides, only lithium will form the nitride. Remaining others do not form because of the large size. Because of the large size. That is the main reason behind it. Okay. So switching for the next concept. So previously we have learned that nitride treating with water, it will form ammonia. Because we are balancing the charges. In that way we are getting the stable compound. Right. And second thing we are learning, on going down the group, the stability of nitride decreases. Okay. It will decreases due to increase in size of cation. So on going down the group from beryllium, magnesium, calcium, strontium, barium, the size is increasing. So stability will decrease in that case. Next is phosphide. Hydrolysis of phosphide. One thing, let me help you out. What is phosphide? So phosphide. Here we have phosphide, means phosphorus carrying the -3 charge. This is phosphide. So same like nitride, here also we are doing the balancing. So you take the phosphide, phosphorus carries -3 charge. You treat with water. So water contain H plus and OH minus ion. So this is carrying charge is how much? Charge is -3. To stabilize this -3 charge, hydrogen has, H plus has charge +1. So in short, what we are learning? To stabilize -3 charge, we need, so to stabilize -3 charge, we need +3 charge. Correct? So to stabilize this -3 charge, we need +3 charge. So that will be provided by whom? H plus ion. So we can say the -3 charge of phosphide, that is P3 minus, will be stabilized by 3 H plus ion have +1 charge each, right? +1 charge each. So let us do in that case. So P3 minus plus 3H2O, it will form PH3, formation takes place in this manner. So it will be stabilized, right? It will be stabilized in this manner. So we can take any example. Okay, we can take any example for the phosphide. So suppose I take example here phosphide. So side by side 3OH minus formation takes place. So let us take an example of calcium phosphide. Let us take an example of calcium phosphide, Ca3P2. Calcium phosphide. Now there are 2 phosphorus atoms and our target is to formation of phosphine. So 2 phosphorus atom on the left hand side. On the right hand side, there will be 2 phosphorus. And how many? Each phosphorus carries -3 charge. So to stabilize this -3, we need total 2 into -3, that is -6 charge. So to stabilize this -6 charge on phosphorus, we need 6 H plus ion. So we write 6 H plus. So 2 into 3, that is 6 hydrogen. Each hydrogen has +1 charge. Plus formation of 3 calcium hydroxide takes place. This is a reaction. In this way we do the balancing. Other examples of these, what we learn? All we have to do is to balance this -3 charge with the H plus ion. In that way the hydrolysis of phosphide will be balanced out. So same, another example, we have calcium phosphide, then you can take the other also, magnesium phosphide, Mg3P2. Magnesium phosphide reacting with water. So charge on phosphorus, we know it is a -3 charge on phosphorus. So here simply we can say charge on phosphorus in Mg3P2 we can do. So there are 2 phosphorus atom, 2, and each phosphorus carries the -3 charge. So overall charge will be -6. To stabilize this -6 charge, we need 6 H plus ion. So here to get the H plus ion, we just put up. Here let us balance. So there are 2 phosphorus on the left hand side, 2 phosphorus on the right hand side. 6 H plus ion. So we have to do 6 water molecule we have to add on the right hand side, and total 6 hydrogen will be there. So H2O means consisting of H plus as well as the OH minus ion. So now here H2O means 6 H plus and 6 OH minus will be there. So -6 charge will be stabilized by 6 H plus ion. In this way it is balanced. Similarly, there is magnesium. How many magnesium on the left hand side? There is 3 magnesium on the left hand side. On the right hand side it should also be equal. So 3 magnesium on the right hand side and remaining, and we know magnesium has +2 charge. To stabilize this +2 we need 2 OH minus, right? So charge on magnesium in magnesium phosphide 3 into 2, that is -6, that is +6, sorry. To stabilize this +6 we need 6 OH minus. In this way it is completely balanced. So this is the hydrolysis of phosphide. You can take another example. We have plenty of example for this. So another example if you want to take, you can do strontium phosphide. Same like the previous one. All we have to do here, the phosphorus is carrying -3 charge and there are 2 phosphorus atom here. So let us write the 2 phosphorus on the right hand side here, and total charge 2 phosphorus atom each carrying -3 charge, total it is -6 charge. To stabilize the -6 charge overall on the phosphorus we need 6 H plus ion. So we put 6 here and it will form in this manner, that is phosphine formation. And there are 3 strontium, each strontium carries +2 charge. So we write the 3 Sr, and to balance this +2 charge of strontium we need 2 OH minus. So 3 into 2, that is +6 charge on strontium overall in strontium phosphide. So we need 6 OH minus. In this way the balancing has been done, right? So overall the target is to get the phosphine. In this manner the balancing has been done. Next, going for the hydrolysis of hydride. Now hydride is there. Hydride, it means hydrogen will carries the -1 charge, right? Charge on hydrogen, it is -1. Oxidation number, or we can say the charge on hydrogen, is -1. So to stabilize this H minus we need H plus ion, right? To stabilize this -1 we need H plus ion. One idea is there. So here water molecule means consist of H plus and OH minus. Now H minus will not react with OH minus because hydrogen carries -1 charge, hydroxide also carries -1 charge. So in that case both are having the same charges. Always remember, opposite charges repel each other. Opposite charges repel each other. So in short, what we have to do? This H minus will react with the hydrogen, H plus ion, to form which thing? Hydrogen gas, H2 gas. So I can show with example. So here we take sodium hydride. This is sodium hydride. So in sodium hydride, sodium carries the +1 charge and hydride carries -1 charge. So when it reacts with water, right, water consists of H plus and OH minus ion, correct? So when it reacts with water, it will form, so this -1 will be stabilized by +1. It will form hydrogen gas here, and sodium carrying +1 charge will be stabilized by the OH minus. In this way, NaOH formation takes place. So this is a way to stabilize the hydride. We can take another example of this. So here, which thing forming? We are forming the sodium hydroxide and hydrogen gas will be liberated. So this is the hydrogen gas which is produced. We can take another example. We can take magnesium hydride, MgH2. MgH2. So there are two hydrogen atoms. There are two hydrogen atoms in the magnesium hydride, and hydride, hydrogen carries the -1 charge. So two hydrogen atoms in magnesium hydride, overall charge on hydrogen becomes -2. So we need water molecule. Let us write. Magnesium on the left hand side is 1, right hand side also it will be same. Now hydrogen, here this hydrogen carries, each hydrogen carries -1 charge. There are two hydrogen, means -2 charge. To stabilize this -2, we need two water molecule in that case. So in short, 2 bracket H plus OH minus. So here it will form the 2 hydrogen gas in that case. So 2 H2 gas it will produce in this manner. Because here hydride, this is a magnesium hydride. So magnesium hydride reacting with two molecules of water, it will form the magnesium hydroxide and liberation of hydrogen gas takes place. Liberation of hydrogen gas takes place in this manner. Similarly, here again aluminum hydride reacting with 3 water molecules, and it will form aluminum hydroxide, same manner. Because aluminum carries a +3 charge, hydrogen carries -1 charge, so we need 3 hydroxide ion and liberation of 3 hydrogen gas takes place. So in this way we can do the balancing of the hydride. In the hydrolysis of hydride, hydrogen gas will be liberated. Hydrogen gas will be liberated in this manner. So these are the idea. So hydrolysis of water, hydrolysis of the hydride, it will forms the hydrogen gas. Switching for the next. Next is carbide. So carbide means carbon carrying -4 charge. Carbon carrying -4 charge, we can say this is carbide. Right? Carbide. So carbon carrying -4 charge. Here the charge is -4 in this way. So it is treating with water. And we know water consists of H plus as well as the OH minus ion. So to stabilize this -4 charge, we need 4 water molecule because it will generate 4H plus ion. Hence it will form the CH4 molecule and liberation of 4 OH minus ion takes place. 4 OH minus ion will be forming in that case. So if we take another example, aluminum carbide, Al4C3. This on treating with water. Here, how many carbons are there? 3 carbons. And each carbon carrying -4 charge. So 3 carbon means 3 into 4, that is 12. 3 into 4, that is -12 charge. To stabilize this -12 charge, we need water molecules in that case. So our target is to form the, first we write 3 carbons and 3 into 4, total becomes minus 12 charge. To stabilize this minus 12 charge, we need hydrogen, CH4 target. So 3 into 4, that is 12. So we need 12 water molecule in that case. And here the formation of 4 aluminum hydroxide takes place. So in this way we do the balancing. And our product, that is methane formation, takes place. So hydrolysis of carbide will give the methane gas. Similarly, other examples are also there. You can do about it also. So other example, beryllium carbide, Be2C, this reacting with water. Beryllium carries plus 2 charge, carbon carrying minus 4 charge. So beryllium carbide reacting with water, it will form methane compound plus formation of 2 beryllium hydroxide takes place. Right? So 1 carbon, we need 4 H plus ion. So this carbide is having the minus 4 charge. To stabilize that, we need 4 water molecule. So here in this way the balancing has been done. So hydrolysis of carbide gives the methane in case of the aluminum carbide and beryllium carbide only. Next we can take for sulfides. In the sulfides, so in short what we done, sulfides. Sulfide means sulfur carrying minus 2 charge. So if we do the hydrolysis of sulfide, we are getting which thing? H2S gas, that is hydrogen sulfide. We are getting hydrogen sulfide here. Correct? Now how to do the balancing? Sulfide S2 minus charge. This when we treat with water, like the previous one, water consists of H plus as well as the OH minus ion. Correct? So sulfide here, sulfur is carrying charge on sulfur. Charge on sulfur is minus 2. To stabilize this minus 2 charge, we need 2 H plus ion. So we put 2 here, so that the number of H plus ion become 2. So when we deal with it, we are getting the H2S gas, because hydrogen carries plus 1 charge and sulfur carries minus 2 charge. In this way, 1 sulfur carrying minus 2 charge, 2 hydrogen each carrying plus 1 charge. Overall, we can say 2 into plus 1 plus minus 2. Overall charge becomes 0 in this manner. Overall charge becomes 0, so H2S formation takes place and liberation of 2 OH minus happen. So let us take certain examples. We take an example of sodium sulfide, Na2S. Sodium sulfide reacting with water. Our target, H2S gas formation. So sulfide, sulfur carries minus 2 charge, sodium carries plus 1 charge. Here H2O means it consists of H plus as well as the OH minus ion. So here sulfide, sulfur carries minus 2 charge. To stabilize it, we need 2 H plus ion. It is only possible when we multiply the water by 2. In this way, it is forming the H2S as well as the formation of OH minus happen. Now here, in this case, there are 2 sodium. Each sodium carries plus 1 charge. So to stabilize the 2 sodium having plus 1 charge each, first we write 2 Na on the right hand side, and overall charge on sodium in sodium sulfide 2 into plus 1, that is plus 2. So we need 2 OH minus ion to stabilize the Na plus. So in this way we are doing the balancing. In this way we are doing the balancing in this manner. So most of the reactions balancing we have done here. Most of the reaction balancing we have done here. So if you want the more example, I can show more also. Let me clean this up. So let us take another example. Another example we have the calcium sulfide, CaS, right? Calcium carrying plus 2 charge, sulfur carries minus 2 charge, calcium sulfide. So this on treating with water, we are doing the hydrolysis. Our target is to form the H2S. This is our target, right? So here sulfur is only 1. and on the right hand side only one sulfur. To stabilize this -2 charge, we need 2H plus ion also. So we need 2H plus ion. That is only possible by multiplying the water by 2. In this way, and calcium is only 1. So we write calcium here. Now H plus ion. So 2H2O means 2H plus and 2OH minus ion. So if we do the balancing of these, so 2H plus will be utilized by this sulfide ion. Here are H plus ion. And 2OH minus will stabilize the calcium, because calcium carries +2 charge. So in this way we can do the balancing. In this way we can do the balancing, because calcium is carrying +2 charge in calcium hydroxide and OH carries -1 charge in the hydroxide. Right? So this is the idea regarding the hydrolysis. So this is all about the KGF hydrolysis, KGF trick for hydrolysis. Thank you. Like, share and comment. Share as much as possible and press on the bell icon and share it to lot of people. Sharing is caring and you can learn better also. So press on the subscribe button.